During today's workshop, what we will do, we'll first do a simple greenfield analysis example, so it will not take much time. So about 10 minutes probably. Then we will do network optimization with Ciplex in order you could see how it really works now. And then we will do the most interesting part of today's workshop. This is ALX extension with AnyLogic Professional.
So create number of clients. I think that's enough. And I will define a product. So you see, this is the list of tables that contain the data of the scenario. And on the top we have like filters. Now we see all the tables, then tables needed for greenfield analysis, network optimization, and simulation. So greenfield analysis, very simple, just for tables. So I create a product, well, we'll leave default name here, and I have to specify demand. When we create a customer using the map, the corresponding demand is created automatically. So all we need is to set up a newly created product in this demand. By default, it's all equal. So it's periodic demand, and we order, customer orders 5 units of product every 10 days in this case. You can also use historic demand, and in this case you specify exact transactions, exact orders that happened in the past or you expect to happen in the future, depending on what kind of problem you solve right now. Moreover, you can export the whole scenario to Excel and use it as a template, so you can populate it knowing the structure and then import it back to AnyLogistix. We have a database. All the data is stored in database in AnyLogistix, and we have number of supported databases, and we extend that number on demand. So as you see, here we see default database, and it's a lightweight SQLite database, but have number of supported types. It's Microsoft SQL Server, Oracle database, Postgres, and MySQL. And HSQLDB is Java-based in-memory database, which is quite fast for small amounts of data when you can fit everything in RAM. Greenfield analysis. Very straightforward. Not too much parameters. You can actually switch. So you have 2 options. You either try to find desired number of sites, or you define maximum service distance, and then you identify the least number of sites which will serve all the customers. On the right we have a table with all possible sources and groups of sources. And currently we have just all customers, and we want to identify a number of sites required to serve customers within 600 kilometers. That's it. Very fast. So that's how it looks like. So when you put desired number of sites, then it tries to minimize not the travel distance, but the cost associated with it, because it really respects the demand each customer has. And if some customer has huge demand compared to others, then it will pull the warehouse towards him. we can convert the result to a scenario, and now it has all the data there. So you have locations of sites as well, and the distribution center associated with them. So what we can do next, we can choose new scenario with already existing distribution centers and select all sites, simplicity, and run again. And well, it's strange to try to find 3 sites for 3 warehouses, right? So we will find one. And yeah, I guess it is located right on top of existing one, and that means that the demand in this region is greater than in all others. Just to demonstrate that to you, I will move it. Yeah, that is this proposed distribution center, and it was located right on top of that. Another important thing we will have in 2.5 is different measurement units, which will allow you to transform or define correspondence between, for example, unit and pallet. Sometimes it's convenient for you to measure flow or storage capacity in pallets rather than in cubic meters or individual product units. So we're going to add this, these units of measure. I mean that you will be able to add your own units of measure, like some pallets or, I don't know, boxes and correspondence between them. Next stage is actually to take an expert look on what greenfield analysis proposed to you and choose potential locations for your facilities based on their real availability, whether you can rent a facility or build a facility depending on size of your company or on your plans or whatever, availability of workforce and so on. So in classical approach, what you do, you just put warehouses exactly where they really could be, near the places proposed by greenfield analysis, just like that. So here, probably here, and here. Well, it's pretty close to Memphis, right? And so on. Greenfield analysis points you the region, the region based on both travel costs and demand, right? And then you try to find the really best location. Since you consider real locations, you also can define specific properties of each location, like initial cost, facility closure or closing cost. So, and it is applied when you already have your own supply chain and you try to understand whether you should close some facilities or you still need them to operate. And in some cases, closing cost can be negative. For example, you sell the warehouses and you earn of that. Inbound processing cost, outbound processing cost, it's straightforward. Interest applied to the inventory you have, to the corresponding money amount that stored products cost.
Yeah, this is needed to calculate opportunity cost.
Yeah, opportunity costs, right. Then other costs, just regular monthly costs for a facility, then carrying costs, to the amount of money you pay for storing like 1 cubic meter of products, and facility costs vary depending on size of facility. Okay, so let us define some parameters for these sites. I will put some values here. They can be different depending on location, right? For example, these ones are cheaper to jumpstart, but probably inbound processing cost will be higher. I'll put 9 here. And here we will have 6. Okay, probably that's enough for our case. So what I'm going to do next, there is a setting called initially opened. So that means at the very beginning of experiment, this facility is either operating already or not. And I will set all of them to be initially closed. So we do not have these facilities, and we just try to understand which ones we need. I will turn off greenfield analysis results because they're just pointing us good locations for real sites. Yeah, or areas. And I will say that we consider all others. What else do we need? Actually, we need to specify which sites work with which products. In this case, it's pretty straightforward because we have just one product, right? But that line works well for all the products, right? So this is the constraint that, or table that serves 2 purposes. The first one is that it defines whether a particular site can deal with particular product. And it can be defined in 2 ways. You can specify it explicitly, like this, site and product. Or you can specify group of sites or group of products and say that it should be expanded. And that means if you have all the groups expanded, then it means that you have individual constraints defining that the site can work with this product. Another setting is time period. Now we have just one time period for the whole scenario duration, and all periods works well here as well. Okay, we cannot take products from nowhere, right? So we actually need a supplier. And in case we do not care about the cost associated with its supplier's responsibility to deliver goods to warehouses, then you can regulate that using path. So instead of having routes from all locations to all locations, I will have a route from supplier to well, I have to create a group of sites. And I will create a group of customers as well. And put all customers there. So going back to path, we will have zero cost associated to delivery from supplier to sites. And well, let's define it volume-based. So it's cost for transferring 1 cubic meter by 1 kilometer, and it will be 5 cents. So we create a network optimization experiment. Well, which one? Yeah, that one. We have a couple of options here. That one can be used to understand which customers you really should serve, and or which customers are profitable for you and which are not. If the satisfied demand is at the lower bound of the range defined for the demand, then it means it costs you something to serve that customer. But if it goes to the upper bound, that means that you earn having this customer. Okay, let me switch back to demand. So the exact amount of product that is demanded is calculated from this field. Let's assume it's like 100 units per period. When you have some penalties for not satisfying it, right, associated with that. So when you solve your optimization problem, you get a result that you should satisfy that demand. But what does that mean? That means that penalties for not satisfying it are higher than when you satisfy that demand. But if you switch it from being a strict, just one value, to a range, you can understand whether you earn from having this customer or you really lose money satisfying this demand. Here we are. We've got some results. And you can see that here we have straight, or as the crow flies, routes. What we will do next, we will rerun this experiment using real paths. At least between sites and customers. So it will take longer this time because now it downloads routes from our routing server. So I left routes from supplier to be straight, but all others are based on real roads, and these distances are considered in optimization. And we actually can compare. Okay, you can see that the second best solution is already different because of these routes. So it really influences the solution. you can import exact paths here. I mean that rather than specifying groups, you can specify all real costs you have somewhere. As it might be like that. Okay, if it's LTL, then probably it's volume based. So it will not be connected to distance anymore because you specify exact route, and you just tell the system how much does it cost to transfer 1 cubic meter or 1 kilogram of goods. I will create a new project just to, not to mix it with scenarios we just created. First of all, I would open, okay, I will open just an example included in AnyLogistix. Well, it's Germany, okay. And I will run simulation. And what we have here, we have warehouses and clients. And what we're going to do right now, we see, you see, we have some logic associated with client object. What we will do now, we will create our own implementation of customer from scratch. So I go to extensions and press run AnyLogic. So what I have here, I have a template for a customer that will that can be plugged in AnyLogistix. And actually, it really have to support two main processes: generate orders and receive shipments, right? So what we do next, we will go to AnyLogic palette, choose process modeling library, and add a source which will generate orders. So here I specify that this object generates agents of order type. And just let me check. And arrival rate will be one order per week. So we will order each week, right? So what else do we need? We actually have to specify the amount of or number of items we order each time. So I will go to on at exit field, and I will type actually some code. Agent which relates to order in this case. We have to change type to. Oh no, not here. Sorry. So we will order 2 products, and we will specify who created this order. Yeah. Okay, great. So we already implemented. So in this template, we already had a placeholder for ordering process, and this is the exit point which is connected further in supply chain. So we have to feed orders there, and we took standard AnyLogic object for generating agents, and we said that it generates orders, and we've put some parameters here. So we specified amount of product we order each time, and we set the owner of this order to identify, so that supply chain can identify, or upstream can identify whom it should ship the product, right? So now I will switch to ALX lib. We do not have icons yet, but these are this is the library that helps you to extend AnyLogistix objects. So it can deal with ALX internals, and I select sourcing object because currently we are generating orders, but we do not know where to address it, right? So I put sourcing object in between order source and outgoing order, and passing through that object, the order gets information where it should be routed, to which source. This sourcing object deals with this sourcing table. And if a customer has number of sources defined and some policy to choose, for example, the cheapest or the fastest or the closest one, then this object will select that source respective to what is defined in that table.
And by coding, can I define that if I have an order for a contract, I can supply 50 from that DC and another?
Oh, absolutely, yeah. Well, using the code, you can actually split that order manually for 2 orders, and then select respective sources for each of those. On top of that diagram, we have number of functions that are needed to integrate an object to supply chain. And one of the functions here is init sourcing, which actually populates the sourcing object with all the data from sourcing table. We need to introduce something unique, and this uniqueness will be loyalty. So sometimes our customer, depending on the loyalty value, decides not to buy from our network, but goes to competitors. And that's what I'm going to implement right now. And the good moment to discard an order, I think, is before we start searching sourcing, right? So I will again use standard AnyLogic block, which is select output. And I will add sync order to discard orders that virtually go to competitors. Then we need a personal loyalty variable. So I add new variable, call it loyalty, and let's put 0.8. So every fifth order goes to a competitor from a customer. Okay, great. I think we already can test again what we've got. So again, I export this model to AnyLogistix extensions folder, then rerun AnyLogistix. I will check that we still have the same customer templates. Yeah. So let's run it again. So we can see that some orders are discarded and do not get into our system. And that's exactly what we wanted to. Well, original intention was to update loyalty based on service level, right? So, well, it's a natural idea, right? Straightforward.
We are actually done with the workshop program. So now, so if you have any question, just feel free to ask us.